Hi guys, it's Eric, and today I'm going to be going over how to read a multimeter. I believe every household should have a multimeter. These are very useful for any project around the house that includes electricity. With this, you're able to tell if the power is on or off to an outlet, if a wire is live and currently has electricity flowing through it or not, which can be helpful in preventing you receiving a shock. You can also tell if a battery is charged. Your rechargeable batteries for various objects throughout the house, you can tell if they're charged or not. Your typical multimeter includes the multimeter unit itself, and this can be digital or analog, although most multimeters nowadays are digital. This one's digital and has a backlight function as well. This is a useful function because oftentimes when you're working in an area where you've turned off the power, you won't have any light. So the backlight function on a multimeter is really nice. This one also features a stand, which you can use to sit flat, or you can have it stand up so it's easier to read. A red probe or lead, and a black probe or lead. The black lead is normally going to be plugged into the COM port on the multimeter. The red probe or lead is going to be plugged into different ports depending on what you're measuring. Generally, you don't move the black lead out of the COM port. With this multimeter, you can measure DC or direct current voltage, AC or alternating current voltage, continuity and resistance here, as well as amps. We're going to start with DC or direct current voltage, and we're going to measure something that it uses DC. General things that use DC that we come in contact with on a pretty regular basis are batteries. For measuring anything that uses DC or direct current voltage, you're going to want to plug your black lead into the COM port, and then your red lead is going to go into the voltage port, and that's indicated by, there's a V right here. So we'll just put that in place. The next thing you have to do is position this dial. Now this gray area is for measuring direct current, and you can tell because if you look right here, there's a symbol that's a V with a straight line and a dotted line under it. That's for DC or direct current. Now, as far as the numbers go, you want to set the number to the next highest number according to what you're going to be testing. So if I'm going to test this is a 1.5 volt AA battery. So since it's 1.5 volt indicated by the 1.5 right there, 1.5 V, I want to turn this dial to the 2, which would be the next highest. So we go down to 2. Make sure the meter has zeroed itself out before you start. So I'm going to take the ground lead, or the black lead, and I'm going to put it on the negative side of this AA battery. And then I'm going to take the positive lead, or the red lead, and I'm going to put it on the positive side of this battery. Now you can see that this battery is currently reading 1.622 volts, which is good because it's supposed to be a 1.5 volt battery. That means this battery is a good battery. Now we'll do the same thing for this battery. This is my rechargeable drill battery. Now it's supposed to put off 18 volts, which is much higher than the AA battery. So for this battery, we're going to have to move the dial. The next highest is 20, and it's supposed to put off 18 volts. So we'll move this dial to 20, and this battery is labeled here with positive and negative as well. So again, we're going to take our ground probe and we're going to connect it to the negative side of the battery, and we're going to take our positive probe, or our red probe, and we're going to put it on the positive side. Okay, the multimeter is giving off an error. The reason it's giving off that error is because this battery is actually putting off more voltage than what I have it set for. It's supposed to put off 18 volts, but it's probably putting off more than that. So what I'm going to do is I'm going to take the multimeter and I'm going to change it to the next highest number, which is 200. And as you can see, it moves the decimal place over. So again, I'm going to do the same procedure. We'll connect the black to the negative and the red to the positive. and we'll see if we get a reading. There we go. We get a reading of 20.7. As you can see, that was higher than the 20 that we had it set for before, which is why it gave me that error message. So this battery is putting off 20.7 volts of power. It's a fully charged battery. If you're ever not sure about how much voltage is supposed to be coming off of the item that you're measuring, you can always start at the highest number and you can gradually step the voltage down until you get a reading that makes sense to you. Okay, next we're going to measure alternating current, or AC. For that, we need to take our dial, which was on the DC side, and move it to the AC side, which is indicated by this little icon that's a V with a little squiggly line. That stands for AC. So we're going to move it to 200, because a standard wall socket here in the US should put off 110 to 120 volts. When you're measuring high voltages like this, you want to make sure that your meter is capable of reading that high. This one is fine because its highest rating is 600 there. And we're only going to be measuring between, as I said, 110 to 120. When you're measuring voltages at a wall socket, you want to make sure that your fingers don't come anywhere near the tips of the probes and that the probes do not touch each other when they get near the wall socket. Okay, what we're going to do is we're going to take our ground lead and we're going to put it in the big side of the plug, just like that. And then we're going to take our red lead and we're going to put it in the small side. As you can see, this is putting off 117.9 volts. This is a good wall socket. It's putting off the correct voltages. The next test we're going to do is going to be resistance. Resistance is basically how easily electricity flows through something. So, like a cardboard box like this, electricity would not flow through this very well. But a wire like this has almost no resistance. So we're going to test the resistance of this USB charging cable. To measure resistance, we're going to move the dial to this side, indicated by this little icon that looks similar to a horseshoe type thing, but this is the symbol for ohms, which is how you measure resistance. So I'm guessing the resistance of this wire, this USB wire, is actually very, very low. So I'm going to change it to the lowest number on this meter and we can see if we can actually get a reading. The lowest number is 200. That's actually really, really low. So we'll turn on the backlight so you guys can see, and we're going to measure the resistance of this wire. I'm going to take one probe and I'm going to put it on the outside, the metal part of this USB cable, and I'm going to take the other probe and put it on here. And as you can see, we are getting a resistance reading of 0.3. We're already at 200, so that's actually a really low resistance rating, which is what you want for a charging cable like this. That's how you measure resistance. Okay, now we're going to use our multimeter to measure continuity. Continuity is basically checking whether you have a complete circuit or not, whether electricity is flowing through the actual circuit. Your multimeter is going to send a really small signal through whatever it is you put the probe on, and then it's going to check the other side to make sure that it's completing itself. In order to check continuity on this multimeter, you have a little icon here that looks like a sound wave. That's because the multimeter is going to make a sound if the continuity is good. So I'm going to turn the dial to the continuity meter. Again, we're going to take one end of our probe and we're going to put it on this USB cable here. And then we're going to take the other end and put it on this end. And you can hear the sound that the multimeter was making. That shows that you have continuity, and this is a good cable. One important thing to note when you're testing continuity, you want to make sure whatever device you're testing is unpowered. So disconnect it from whatever power supply it's on. Those are the basics of using your multimeter at home. I hope you guys found this video helpful. Thank you for joining me for another problem solved.